Hello, good afternoon, good morning, good night, depending on where you are and when you are watching this. So, I am Karina Varela, and I'm really happy to have you here today on the yeah, we
12.
are yes, we've done a lot of key lives already, Alex. And Alex, good afternoon, by the way.
Yeah. Good morning, good afternoon, good evening, whatever. And yes, it has been nice. It's just 12. And for today, we have a very special guest. Can you tell me more who we're going to have today?
This guy has more than 20 years of technology experience, and I'm bringing here a lower number than the reality because I don't want to reveal his age, but just working with business rules engines or business rules automation. He's working for more than 16 years, including the time that he was not yet a red hatter. So I'm pretty happy to have here today Edson Tirelli. Alex, do you know this guy? Like just for a couple of weeks, right?
Oh, yeah. And people may not know, but Edson is guilty to bring me into the project. So I have a great debt of gratitude to him. So many years ago, we were starting to exchange some emails in mailing list as an open source, right, community. And after some exchanges, we have a common friend that introduced ourselves among us, and the rest is history.
That is so nice to hear. I didn't know about the story, Alex. And
Yeah.
by the way, if you are here today and to know more about business rules, let me just give you a glance. We're going to discuss like why should you care about rules automation instead of doing your traditional if and else logic in your code, right? Why should you consider using a rules engine? What is new in the business rules automation space and decision automation space? And what is the difference in between these two things? How does decision automation aligns with AI technologies? How we can connect them together in order to bring more benefits to our application?
Okay, we have a lot to cover. So let's bring in Edson.
Let's bring him. Edson, welcome to stage. How are you doing? Thanks for accepting our invite.
Hello, everyone. Thank you for the introduction and thank you for having me here. It's a pleasure to talk to you.
Yeah, oh, it's a pleasure for us to have you here, Edson. So, Edson, just before we start, tell us where you are based. We always like to know where we are, where our guests are when you are talking to them.
So I live in Toronto, Canada. I've been here for 12 years now, but I am Brazilian born, so um, I have many friends down there in Brazil.
That's pretty nice. Porcelli, is there any question that you want to bring, Edson, before we start the deep dive? It is not a deep dive. It's actually an overview, right? It
Um,
is not yet a deep dive. We can do a deep dive month, but it's not yet a deep dive.
yeah, no, I think we are ready to grill Edson.
This is pretty nice. So, okay, Edson, and I see here our folks who are always joining, and so I'd like to say hi to Singaram, Guilherme, hey, JJ, Ravi, Kirill, Fernandito, everyone is here. How are you doing, guys? Thanks for joining.
Hello, everyone.
Um, and okay, so let's get this started. Edson, okay, could you please start by explaining our viewers what is decision management and why does it matter? Why is it important?
Of course, decision management in this is a discipline that deals with automation of decisions. So it's part of business automation in general, but it deals specifically with decision, automation and management in general. It is important because it brings to the business effectiveness, efficiency, and consistency. And let me just quickly explain this. effectiveness is about making decisions in a timely manner. So if you have a customer that you need to, ship a product to, or if you have a customer that is at risk of leaving and you want to offer him a promotion to stay. So those are actions that require timely actions. So that's when the decision automation helps you make those decisions in a timely manner. And then you have consistency is about making the same decision the same way every time, so that you don't do one thing for one customer, a different thing to another customer, or one thing for the government this week, and then next week you do something different and risk breaking an SLA or something in that sense. And effectiveness is about making the correct decision every time. So if you have if you have to take action, that action has to have a positive net effect to the business. So this is basically the three concerns that decision management deals with.
Okay, and now I have a question. The first question: how is this different from my traditional coding and programming that I do in my Java or any language?
That's a very good question, and we get asked that a lot. I think the easiest way to explain is by comparison. So I often compare, a rules engine or a decision management engine to databases. So the same way that databases manage your data for you and offer you a specialized algorithm, a tool that can help you in many different areas of managing data, decision management tools help you with the decision part of your business. So your business rules, you can manage them outside of your normal life cycle of the application. They can have their own life cycle. The engine itself is an extremely efficient algorithm that can give you, the performance that you need in order to be successful in the application implementation.
Okay, now I think it's way more clear. It's not just, we are just not replacing if and else. So there is a structure behind that. That's very clear now. In getting back to your answer, is you mentioned about operational decisions.
Mm-hmm.
So are there any other types of decisions and how they are correlated with decision management?
Yeah, there are basically, when we talk about decisions, there are two main categories, if you will, of decisions: the operational decisions and the strategic decisions. So operational decisions are those high volume, frequent decisions that businesses make every day. It's about, pushing that button, virtual button, if you will, or automating that task, automating that response, calculating the risk for the customer, and etc. So it's very targeted, very simple and high volume decisions. The other type of decisions are the strategic decisions, and those are more related to long-term business impact. Where do I want to, drive my business to? What will I be targeting? What will be my product in the future, in a year, 5 years from now? What kind of customer I want to address? Those strategic decisions, usually they require human knowledge and human creativity, human experience. So they are very hard to automate. Even the AI that we have today everywhere, it's not capable of doing those. However, those are very few decisions and very sparse in time. So you don't make them every day. You make them plans for the next 5 years, right? Those thousands of small decisions that individually have very little impact, but on a whole make a big impact on the business, those are the target decisions that we aim to automate using technologies like decision management.
Oh, gotcha.
I see. And still, I mean, we've been talking about decisions, and traditionally we are used to talking about BRM systems, like business rules management systems. So what changed? Why are we talking about like business rules and now we're talking about decisions? What changed in there?
So at the end of the day, they are kind of the same thing. It's just that usually a decision is something that has value to the business. And a business rule is a unit of computation, if you will. So you need several business rules in order to make a decision. So that's basically it. So it's the same thing at the end of the day. But when we talk decisions, we say a group of business rules that aim to automate a decision.
Perfect explanation. Thank you, Edson. And we're talking about all this, but where can I apply it? What are the typical use cases that we might have for decision automation?
Oh, that's also a very common question we get from our users. In the values where the places where we see the highest value are when we apply this technology to scenarios and use cases where we have many rules that are often executed and that they change very frequently. So we have to manage them in independent life cycle in order to get business agility, or we have to manage them individually. And here we have a slide that shows some use cases. But risk calculation, the situations where we have loan approvals in banks and all kinds of financial operations, situations where we have fraud detection, situations for customer retention. All of those cases, they require us to evaluate lots of rules very frequently, and those are the scenarios where we see the most value extracted from this technology.
That's great. And well, it can be more clear to me. It's very clear. I have now, let's connect this decision management to the Drools project. We started this by you have long time history on this space, and I think it all begins in Drools project. Can you talk a little bit about Drools?
Yeah, I felt actually quite old when Karina was doing the introduction, but yeah, it's been a long road.
I'm sorry about
it. Well, you can tell, right? Yeah, so I started with the Drools project back in 2004, so 16 years ago. First as a community member, we are adopting that at the company I was working for at the time. Later on,
which version was it back then?
That was Drools 2.
2?
Yeah. For those that don't know, the very first version of Drools, because Drools 1 was never released. So, yeah.
We started that too, okay.
Yeah. We are fast like that. Anyway, we started with Drools 2 at the time, and then I helped with the implementation of Drools 3, and that's when I joined the team at Red Hat as well. Drools is a platform for decision management and business rules. It contains many components in there. It contains the business rules engine that most people are familiar with. It contains the DMN engine more recently for the DMN standard. It contains an optimization engine, OptaPlanner, that is used for optimization of resources, optimization of decisions, and etc. And it's also seamlessly integrated with JBPM, that is a project for business process management. And more recently, you might have heard we are adapting and rewriting parts of the code to be cloud native, to address the current landscape of technology, and we are branding this under the Cogito project. So that's that's where we are right now.
Pretty good. And just one thing before we move on.
Mm-hmm.
I see a couple of questions here on the chat. I see them. Keep on
Mm-hmm.
sending them. I'm just holding them for the moment when we start talking about these topics, okay?
Yeah,
Feel free to keep on sending them. So, okay, we are talking about the Drools project. And so, at the end, Edson, how does Drools effectively help with decision management?
So, well, besides being, a specialized engine, as we were discussing, high performance, low resources, low resource consumption.
Because that is all technical, right?
Yeah, that's all technical. But from a user's perspective, Drools offers a number of higher level metaphors that you can focus on when developing, and automating decisions, right? Sorry?
It has metaphors. Like,
Yeah.
Can you talk more about it?
yeah, we call metaphors, and those are ways to represent decisions and business rules. So, for instance, a decision table, right, or a high level rule, as in DRL on our native rules, right, is different from the if them else that we are used into imperative programming, right? So Drools offers decision tables, offer technical DRL rules, offers higher level DMN models. In all of those are called metaphors because they are closer to human language than actual imperative code like Java. So, there is nothing wrong with, code. We are all used to it, but the higher level languages and metaphors, they allow us to do two things. One is make it easier for users to define those rules and manage them. And two, behind the scenes, what the engine is doing is compiling those rules and models into highly efficient programs, if you will, that are capable of processing those high volumes of data efficiently.
Gotcha. And with all these models, metaphors that you call, one that in particular that interesting me is the PMML. It sounds a little bit old, like it's from 1990, I think. Wouldn't it be better to just use TensorFlow or any modern or more up-to-date technology around the AI ML?
So, that's a misconception that we hear very often. And the reason here is, there are all those questions about, open standards and the advantages that they bring. And I think we can touch on those as well. But PMML, for those that don't know, stands for Predictive Modeling and Markup Language, is an open standard to represent models. So they are not a replacement for TensorFlow or your Python libraries or R libraries or any product out there that you use. PMML is complementary to those tools and products. And the idea here is that anyone can use whatever tool they prefer to discover a model, generate a model from data, or follow their own way of discovering that model and then training that model. What PMML does is once you have that model discovered and trained, you can persist that model or export, if you will, that model in PMML, and that will give you intercommunication and interchange between different tools. So if you have a tool that specializes and is very good at one thing, let's say, discovering and training a model, and then you have another tool that is very specialized and efficient at automating that and using that model for, let's say, decisions in case of Drools, PMML offers that bridge. that connection between those systems. Is it the only way to do it? No, there are other ways to do it. But PMML has evolved a lot, is a very mature standard. As you said, since 1999, he is around. It is around, and that makes it very stable and supported across a huge number of tools. Pretty much every tool out there that supports machine learning and the creation of predictive models will support PMML.
Good. And I think later on we may touch on standards. I think that's a very that's us as an open source project. We value a lot on these things that I think we touch later. But now back to what you mentioned. You mentioned DMN, PMML, AI, machine learning. Can you unpack that? It's like it seems a lot. Can you expand and unpack?
Yeah, so sometimes people use AI and machine learning as interchangeable synonyms, but they are not, right? AI is the field, so everything we do that is related to creating or simulating intelligence in computer systems is part of AI, and that includes everything from business rules, for instance, is part of AI, right? And you have, computational vision for identifying images, or, automated cars, automated driving, processing images in real time, and then machine learning in general to create predictive models. So everything is part of AI. And then we have, machine learning. And machine learning, if you want to distill this to, the very core of what machine learning is just processing a bunch of data and making sense of that data. So that data can be, past transaction history, can be documents, can be images, can be anything that you have that you want to make sense of. Then you can process that data using machine learning to create predictive models. And that's how it's used more often is, given a certain number of inputs, predictively understand and decide what the output is, right? And then you have effectively decision management. That is, okay, I need to automate a decision, automate a task, and I want to use, for instance, predictive models from machine learning. I can integrate those and use them to create my decision. The diagram that you have on the screen right now is a way to combine both fields, machine learning and decision automation, into a solution that is very effective. So in that diagram, you have on the horizontal axis, your documents, images, your data from, again, database of transactions that you had in the past. And you use machine learning tools to make sense of that data and create the predictive model. And then on the vertical axis, you have, your business data that you're processing on a day-to-day basis, and you can use a decision model to make decisions based on that data. Those decisions can and often do use predictive models to, take actions, to execute business actions. And that's how they correlate. We do have a mention there for DMN. DMN is a standard decision model annotation, a standard for creating decision models. This is an easy one to integrate because it supports natively predictive models. But DMN is not the only way. Like, you can use traditional business rules and integrate, predictive models, or you can use decision tables and integrate predictive models, and etc.
So I see that these systems, they complement each other. We can't use it. We can't only focus on AI to solve it all, and we can't only focus on DMN to solve it all. We can use both to complement each other, right?
That's correct. And this is one of the things that was quite interesting to see. A couple of years ago, I was watching a presentation from Forrester where the analyst was talking about this. And a lot of people don't realize how complementary those technologies are. So in the presentation of Forrester, what they were saying is basically, if you want a pragmatic approach to decision automation, then you need three things there. You need machine learning to make sense of data, create those predictive models. But the problem with machine learning and predictive models is that their results are quite opaque, first of all. So it's hard to explain them, right? And the second is they can give you wild results. A lot of time, if you train the model well, you'll get, for 99% of the cases, you will have results that you're expecting. But there is always the risk of, for a given set of inputs, you get an output there, a response from the predictive model that is quite wild and not applicable to the business, right? So that's where digital decisioning, as they call it, or decision management comes in, because with decision management, you can use the input of a predictive model in machine learning, but you can constrain that to what makes sense to your business. So if the predictive model gives you a wild answer that doesn't make sense for your business, the decision management component can then constrain that and use what makes sense and discard what doesn't. And then you have the mathematical optimization, and that's basically what OptaPlanner does to optimize those decisions. So, okay, you have a constrained output that makes sense to the business, but how can I make it better? Right? And then you use mathematical optimization for that. Or I have several different competing decisions that came out of my business. How do I make sense and choose one of them, or choose, a subset that makes sense? So that's how this framework is used together. Obviously, we're talking about Drools here, and Drools and OptaPlanner, they are focusing on digital decisioning, decision management, and mathematical optimization. But we transparently integrate, and we want to continue to do even, more and more of that integration with machine learning, because those predictive models are so important nowadays.
So I see that this all needs to be connected, and I have a question here. So how is the development of the AI and ML? How is AI ML affecting the development of rules engine based on knowledge system? Rules engine, nossa. How is So basically, how is AI ML affecting the development of the rules engine and rule systems? Because you need to keep up to date to everything that is going on there in order to keep the rules engine aligned with it. So I think that this is where the standards come in, right?
Yeah, the standards help a lot with this. But very good question. And the idea really is that the rules engine community and decision management tools in general, they are complementary to those of the machine learning, as we were discussing, right? Now, how do we make sense of everything together, and how do we bring all of this together? Of course, we can have, point-to-point integrations between each system, but, there are today, I don't know, 100 different products out there of machine learning. I'm guessing I never did the Google search. The same way that there are innumerable, products on the decision management space. How do we get them together and make sense? One-to-one solutions can work well for one customer or another, but they will drive, vendor lock-in. That's where the open standards come into play, because you can use whatever tool is best for you to do the job, and then use the open standards to interoperate between those tools. In business automation in particular, there are many standards, but those 4 that we're showing here are very important and very applicable to business automation in general. And they are, case management, model annotation, CMMN, from OMG. This deals with cases, and cases, for those that don't know, is basically a set of processes or microprocesses that are related but not necessarily ordered to a given business scenario, right? And then you have BPMN two, that is a business process model and notation, also from OMG, that deals with how do I model each of those processes, right? And you have DMN, decision model and notation, that is how do I automate the decisions related to this. And then you have PMML, that is, as we said, predictive markup modeling language. Sorry, predictive model markup language that deals with interchange of predictive models. And when you get all those standards together, you can do business automation end to end.
Yeah, that's what I want to touch base. There's a lot of acronyms there. So can you make sense of all of that? Because it's like, I'm scratching my head. Well, how these all get together?
Yeah.
Once I joined a talk about like BPM systems and how they are evolving, and we spent like almost 20 minutes just trying to figure out all these acronyms. So I would love to hear this from you, Edson.
Yeah, I mean, I like using examples to explain how this fit together. So it is a kind of a puzzle as we saw there, but it's very easy to understand, very logical. Okay, so maybe we can show some slides with examples. So here is an example of a case to manage disputes. So imagine you have a business that wants to automate disputes opened by customers, and you have a set of possible processes that deal with this. So here you can see, as this is a BPMN diagram for the process, and you start at the top there, start to process a fraud claim, and then you go through, determine the dispute risk and automatic approval. You decide if this approval will be automatic or manual, and depending on that, some of those milestones in the bottom will be triggered. So effectively, you are modeling the process of the business end to end, even if some of those actions are not.
But you mentioned you are taking a decision.
So one of those boxes, one or more of those boxes, can be decisions. So in that case, that second box at the top there, where you say invoking a decision service, there is an arrow there. That box represents a decision. Now, how do you model that decision? You want to give the users the ability to keep, using that at the high level. So the next slide has an example of what that decision could look like. And this here is a DMN diagram. It's very similar to BPMN in the sense that it's, shapes and arrows and etc. But instead of modeling a process, this models a decision. What you see in those score boxes are intermediate decisions that lead to that top decision process automatically, yes or no, at the top. The round circles are inputs to this decision. So in order to decide if I'm going to process automatically or not, I need to know what's the fraud transaction amount, what's the cardholder status, and et cetera, et cetera. And this represents, what decision I need to make. Now, this decision here might depend on a predictive model, because to calculate the risk of a given customer, I can use either a declarative model in traditional decision management, like a decision table, or I can use a predictive model that is created by machine learning based on transactions in my historical database, right? In one of those clipped corners there might be one of these cases. So in the next slide, we have an example of what it would like as a decision table. So as a decision table, I can say that, if my incident count is greater than 3 and the cardholder status is platinum, that's the first row on the table on the left. And then I don't care which age the user is, but I will assign a value of risk 1, right? And I can assign this to everything else. And I can say, my dispute risk, if the amount is greater than $200, the last row on the table on the right, then my risk is 5. So it's my maximum risk. So this is one way of doing it. But it might be better to actually use, again, a machine learning algorithm to create that predictive model out of the database of historical transactions. So how do I use that model inside the DMN model if I'm not, writing a decision table? And it's as simple as this here. So basically, one of those boxes in the DMN model will just say, I want to calculate the cardholder risk. And to use the cardholder risk, I need the age, the number of incidents and the cardholder status there. And I will use a document that is a PMML document. So it's a predictive model in PMML for cardholder risk using, in this case, a linear regression. And that's it. It's as easy as this. You don't need any glue code or any, very complicated Java code, let's say, to leverage this. Is as easy as this. The editor helps you and guides you all the way through. And there you go. You combine machine learning with decision management in a very effective way.
And case management. So here I see that we implemented a whole case, we implemented a whole case scenario.
Yeah.
We used the automation of decisions, and we took advantage. The part where we take advantage of the AI system is actually optional, right? We can do that to improve our decision automation.
Correct. The tools are there for the use, and we always recommend everyone use the right tool for the right job. So if they have a database of historical transactions that they can use to learn and calculate the risk of a customer in this example, then they should, right? Because that will give you a very accurate prediction of what the risk is based on past behavior. Now, if you don't have that kind of data set in order to use machine learning, then replicating the experience of the dispute agents would be best, and then a decision table like the one we showed might be the best approach.
But then something comes to my mind when I see this, because generally the person who has the knowledge to write these rules is not the person who creates these algorithms for the PMML and export the PMML itself. So this data that you insert in here, the data scientist will usually provide it to the decision automation specialist, let's call it like that, right?
That's correct. The data scientist will create a predictive model using machine learning, and when he hands over this to the business analyst that creates this decision model, he will say, well, the inputs for this model are A, B, and C, and that's what the model needs to execute. Of course, the tool itself can inspect the model. So when you see the parameters here, age and holder index, incidents, etc., the tool provides for you. So it reads the model and populates those parameters you already know. But from the data scientist, you have what those parameters mean, right? And that's how the different teams coordinate in order to achieve the common goal.
Pretty good. And let me just one more thing, Alex, before you come up with something new. Could you please go back to the previous slide?
Sure.
So we see here that it's really easy to implement the PMML, the previous one, please. Thank you. No, the DMN one. Yes. So where in this diagram is that PMML model on the dispute risk model, correct? It's just
correct.
a BKM.
Yes, correct. And what is inside that little box there with clipped corners is what was on the slide that we were showing.
Pretty nice.
That's what's inside. Nice. Yeah.
So it all fits together, and this is packaged into a project and deployed as a traditional application at the end.
Correct.
Because we are all seeing diagrams in here, but where is the algorithm? Where is everything, right?
Yeah, so that's actually quite interesting, because there are two ways to actually publish this for consumption, right? One way is a traditional, let's call embedded way. So where you have your application, and during build, you compile all these models and include and ship with your application. That's traditional, where we've done this for years and years. And there is a more cloud native approach that is, I want to publish this as a microservice. And it stands alone as a microservice and can be invoked not by only one application, but this can be shared among several different applications that need the same service in your business environment. And that's totally fine as well. Drools supports both approaches.
Awesome. And now back to the use case that you show us from the business process, going to DMN for the decision and leveraging PMML. But now what makes me wonder, isn't it hard to make sense of all these things? How easy or hard is to connect and visualize and understand what's going on?
I might be biased for the response, but it's actually quite easy. Once you start, because every part of this plays, as a piece in the puzzle, right? So if you need to model a business process, that you just take a BPMN diagram and model that particular process, and that's it. And if as part of that process you need to make a decision, then just bring DMN and make that decision. And if you have a data scientist team that created some predictive models that your business user says, oh, we have to use that particular prediction in order to know or to guess what's going to happen, then bring your PMML model in there. I want to reemphasize this. This is not the only way. You can, let's say you are using a tool that creates a predictive model and serves that model. This is how we usually call, the tooling is serving the model for everyone else. And usually serving the model, they serve that model as a REST service, so you don't need to export as PMML. PMML just makes everything easier. But if you are using a tool that serves the models and you want to continue using that, you can simply make a remote invocation to that service and use that service directly inside your models, inside your business rules. It's totally fine. But PMML makes everything easier because it makes the connection, the interchange between the different tools much easier.
Yeah, but it's too, I'd like to get more in when you are adding this PMML space or the AI, how can easy, because to have an understand what's happening in that, it seems like a black box. Is it possible to get more knowledge, understanding what's happening there?
Yeah, so this is an area of research that is in high demand right now, because there are a lot of situations where you need to make sense of what the machine is doing. You're automating decisions, be it by machine learning or be it by decision management, creating your decision models, and the response to those or the explanation to those decisions is not obvious, right? Especially when you're using machine learning, those models, they are mathematical formulas that you can't make sense as a human, right? It makes sense for the machine. So how do you deal with this? Well, using processes and technologies using open standards and established technologies, you can make it easier for other tools that do this kind of analysis and explanation to do their job. In this particular area, explainable AI, it's called, is all about understanding what the models are, be them decisions or be them predictive models in machine learning, and offer a number of additional value-added features around that. In this slide that we are seeing here, we have decision management in the middle, and again, understand that decision management may or may not include predictive models, as we've seen in the previous example. And then the tooling in the platform gives you everything that is around here, starting with the execution. So it executes and automates your decision, allows you to explain that decision, and okay, the loan was approved because of this, or the loan was denied because of that, right? And then you monitor those decisions to make sure that on the global scale, all the decisions that are being made make sense. And in addition to that, for each individual decision, you can audit them, because auditing is a requirement in order to make sure that the computer is not doing something that is against the law, or that is, against the best interest of the company.
Okay, I think I see where you are going, and is this anything related to GDPR in Europe?
Oh, yeah, no, good point. Yes, it is, and not only that. I mean, there are several countries and regions around the world that are establishing legislation that requires this kind of transparency. Europe was the big first one to do this with GDPR, is General Data Protection Regulation. And among other things, GDPR says if you are making decisions based on customer data, then those decisions need to be explained. And this is very easy to do when you have a person doing the decision. Well, it's supposed to be easy if you have a person making the decision, but when you have machine learning and when you have models that are opaque, how do you explain them? So those researchers in explainable AI, they are targeting this kind of use case. Now, obviously, it's not the only one. We have legislation popping up all around the globe, in California, in other states in the US, Canada, and etc. But also it's about the quality of the service of the company. Imagine that your company establishes a process or a decision that, starts discriminating customers based on their, ethnicity or race, or, gender, or this is a big PR nightmare nowadays, right? You get into a scandal like this, you can have a huge losses in the business because of those. And this kind of technology that opens up those decisions and make them transparent, they allow you to check for these problems in bias, these problems in correctness of the model, as well as obviously be compliant with legislation.
So, Edson, if I request for a loan, like, and I got refused, I got denied, my request was denied, I call there and I say, hey, Mr. from the bank or Mrs. from the bank, I want to know why it was denied. How could this person just use the system to know it? Because we are talking a lot about concepts, but I want to see something, like show me something.
Yeah, so there are many ways of doing it, and this is very much an area of research for Drools and our group, but we already achieved some very impressive results. One of them, you can see a screenshot here in the slide, and it basically analyzes a given decision, any decision. The customer comes up with a model for automating any decision, and the decision has an outcome. A loan was approved or declined. Let's say a promotion for a customer was offered, right? So why was this done the way it was? Why was the decision the way it was? The system analyzes the model and looks at all the variables that are the input of that model, all the data that comes into that model, and identifies which of those features or data pieces are contributing to the result, right? So in this particular example here, it's a sub-decision part of a loan approval process. It tells us that, it's hard to read, but it says, monthly income. So the customer's monthly income is the highest positive contributor for this particular decision, with a 0.61 contribution or weight to that given decision, while the credit score of the customer was the highest negative impact on that decision. So by looking into, for instance, a chart like this, the customer knows that if he wants to improve the result of that decision, he either can increase his credit score to reduce the impact there, or increase his monthly income to increase the positive impact, or for instance decrease his monthly other debts, right? So by looking at those features and the weight that those features have, the system can tell you exactly what is contributing to a given decision. This is quite nice because the way it does is completely independent of model. It's model agnostic, as we say. So you don't need to train the model to understand this. The tool, completely calculates and generates this result for you. Doesn't matter if you're using rules, you're using decision tables, you're using predictive models. It's completely, functional.
How? It emit events to somewhere, like how? I'm techie. I want to know. Just a glance. I know we are running out of time, but just a glance, like a quick glance.
Yeah, so there are many algorithms documented in the literature that can do that. And this one that we used as an example here is called the line algorithm. It's part of a lot of researchers' work. And what it does is it takes a model and try to analyze the weight of each parameter by implementing changes on those parameters and making successive calls to the model. So I'm going very techy now.
We're going a lot deep.
But
that's a fascinating
that's how
topic,
it does.
Right? That's a fascinating topic, and
yes, it is.
New,
it's
right?
Amazing. Yeah,
quite new to at least to our group. But for that, we have next week we have a session just about Trust AI.
Oh, count me in. I want to watch that.
Yeah, we'll have a session that will go. It's still the idea of the getting started. We'll not dig deep, but we'll talk just about that because it's fascinating, and we are close to the top of the hour. We still have some questions in the chat, but it's fantastic.
Okay, Alex, I get it. I'll have to wait until next week. And so with you at home watching us, join us on next Tuesday to learn more about Trust AI. So thanks, Alex, and thanks, Tirelli. I'd like to bring some questions over from the people who are watching us. Are you okay with that?
Yeah, of course.
So let's start from the first one. So, okay, how do we properly version DMN? Like, do you have any ideas?
Yeah, the DMN itself, the model itself, is one of your assets, one of the source that you use for your application or service. So I would suggest that you use a normal tool for versioning of source code. Like we use GitHub or Git repositories all the time, and there is nothing that prevents you from doing that. I actually think it's a very nice way to do it because you can have tools like a plugin that Alex team developed that can show you the changes of a pull request when you change something in a DMN model, so you can see the change graphically instead of just in the source code. So that's my recommendation, to use version control anyway.
Yeah, it makes sense, especially because as we are today in 2020, October 2020, we package it inside a project. And whenever you need to deploy a new version of the project, you should increase the version of the project too. So it totally makes sense in my head to version it along with your project. Why are you smiling, Alex?
No, I'm backing. I'm traveling time. I remember the old days of Drools 5 and Governor 5 that we create a sophisticated mechanism that we use to deploy just the rules outside the application. And we did like it was very interesting in terms of technology, but it was completely off how you usually release software, because when you release, so you have a version control, you have a way to revert changes easily, so it has a standard way. So when we moved from 5 to 6, we standardized out our ecosystem around Maven and more traditional.
Good, good. And yeah, we are talking about DMN, but we have a lot of ways of implementing rules today. We have DRL, DMNs, decision tables, review units. Are there any guidelines? When should I use each of these?
Yeah, so there are advantages and disadvantages to every type of metaphor that you use and every language that you use. So understanding the characteristics is obviously a good and important way to start making sense of all. I'll talk briefly here about a few of these. So DRL is our technical rule language, and in DRL, they are very technical rules. So usually you have a developer involved into that. It's code, so it's a bit harder for a non-techie person to understand it. But it's very powerful. Like the algorithm is really powerful behind this, and gives you a level of performance that other types of assets they can't match. So if you have a system that requires very high performance, very low latency, that you have developers involved in the development of those rules, then DRL, the technical rule, is still your best go-to. DMN is a much higher level model, is graphical, as we saw in the previous slides examples. They are very easy for someone that is not technical to understand, because you have just requirements. To make this decision, you need those decisions under it, and then to make each of those, you need additional ones. So you decompose those decisions into a graphical diagram. So it's very easy for non-techie people to understand, and for you to go as a techie person, even if you are involved in development, to go to take that diagram or documentation that the system generates to your user and say, is this correct? Is this make sense with your understanding? And he will be able to read, understand, and tell you that, right? So DMN is very good for that. DMN is also completely self-contained. So if your system needs to deploy the decisions as services, DMN is a very good candidate, because being self-contained, you can deploy as services with data types and everything, and everything is in there discoverable and usable, right? Now, decision table is a metaphor that is available both in DRL and in DMN. So it doesn't matter if you want to represent your rules as a table, you can do that in DMN, you can do that in DRL, right? And so on and so forth. So every piece of this has a role to play in the larger ecosystem. We are around, reach out, we can help you understand. There are a few books on the subject also help. So we reach out, we're happy to engage and discuss.
Okay, good. I love when I'm speaking on mute. I just love when it happens. I also see here a discussion around invoking REST from within a DMN model. So what would be like the proper way to interact with a served model?
Yeah, so that's how I would do it. The issue here is this. The invocation, so let me start this. DMN has a requirement of being deterministic, right? So everything in DMN is considered to be an input, and then you get the output, and for the same input, you should always get the same output. That is why the standard is resistant to add to the standard the ability to invoke remote services, because you don't have control over remote services. You don't know if they will respond the same thing every time, right? Now, this is the standard part. And if you want to be pure by the standard, then you don't call services from within DMN. My particular stance on this is that you should do what makes sense for the business, right? And if you control an external service and you know that service to be reliable, then there is no problem for you to connect a BKM in DMN to invoke a remote service. It will, you are, becoming responsible for ensuring that that service is reliable, instead of trusting the standard DMN as a standard to do it for you. So that's basically the reasoning behind. There are discussions. We are working on DMN 1.4 now as part, as you know, Red Hat is part of the review task force at OMG, and we are discussing with all the other groups and coordinating around this. And this is one of the big discussions that we are having there. Can we state in the standard that if you are invoking a service, it will be idempotent. It will always, return the same result for the same inputs. And if we can do that in the standard, then we can adopt remote calls within the diagram.
I think it totally makes sense to leverage the company goals, because if you are aiming for interchangeability, is this the proper way to say it? If you are aiming to just have this based on standard and you want to make sure that this will work in whichever tooling that supports DMN, then you should go for standards. If not, that's it. Nice.
Yeah.
And I also see here, Mateo is commenting. Everyone, I just love this interaction in the chat, guys. I really do.
Mateo is the DMN guy. So if you have questions about DMN, Mateo is there for you.
And I'm quite sure that we're going to have a session with Mateo, because we are just finishing then these things that we in the pond and all these rest calls just came to the end, but there's a lot to cover in this space. So we'll have to bring Mateo to go deeper on this topic. And not just that, because over the, you said that some numbers, like it's a performance. I also very curious now if we have any information about how low latency means in Drools. And I think it deserves a session just to go and crush the engine with maybe Mario, someone from the team.
Totally. Because today we learned all the advantages of using standards and how they connect to each other, how they are connected to the evolution of AIML and all this stuff. But there's also a whole world in the engine itself, right, Edson? A whole algorithm implemented just for... do we have Freak implemented in any other place? I think it's something from Drools, right?
Yes.
We created it for Drools.
Yeah, this is an algorithm that, Mark started the research, and, several other people contributed. Yeah, Mark Proctor. Yeah, and Mario and Eduardo and others, they all contributed to the development of this algorithm. It is based on the old RITI, algorithm that was designed a long time ago, but has so many advancements and so many advantages over the original algorithm that it is what it is today. So I think the idea of a performance session is great.
Yeah. Okay. We are getting over time, I'd say. But any finishing thoughts, Edson, before we go?
No, thank you for having me. It was a pleasure to be here. I hope this was helpful for our audience there. And feel free to reach out, anyone, if you have any questions that I can help you with. I'm happy to discuss. Thank you.
Thank you very much, Edson.
Thank you for joining us today. It was a lovely session. Have a nice day, Edson. Bye-bye.
You too. Bye.
If you are still here today, I'd like to share news with you. So we started testing streaming on Twitch TV. I'll share the link here with you if you want to follow us there and just follow us there if that's the platform you like the most. We will be on streaming on both from now on. And I'd also like to share with you this, if you want to keep aware of any events that we are planning for the Key community, just hit the follow button in this page, because that is where we centralize all the upcoming events. For the next session, Alex, we will have
Daniele to talk about trusty AI, and all this explainability are going to be very interesting.
Daniele Zonka is really good at it. And next, we'll have Eric Chabel here. So subscribe and see you next Tuesday.
Yeah, see you.
See you. Bye-bye. Thanks for attending.